Hello everyone, I'm Faguni, your chemistry SME. So let us start with today's question and answers. So the first question given to us is assertion and reason. Assertion is MX4 and MX2L2 type of complex, where X and L are the monodentate ligands, do not show geometrical isomerism. Reason given to us is complex with coordination number 6 does not show geometrical isomerism. Here this would be the correct option. Why? Because MX4 and MX2L2 have tetrahedral geometry. So, in tetrahedral geometry, they do not exhibit geometrical isomerism at all. And let's see the reason. The reason here is incorrect because cis-trans isomers do exist in coordination number 6. Okay, so it does show. So that is why our option is third. Now, in the next question, it is asked that which among the following is a heteroleptic complex? Let us see what are homoleptic and heteroleptic complexes. The complexes in which the metal is bound only to one kind of donor group. For example, in this, you can see only one donor group, that is H2O is there. Therefore, it is homoleptic. And then what will be heteroleptic? In which metal is bound to more than one kind of donor group. That is why you can see in this option, this is heteroleptic. Therefore, this is the correct option as in other options, all are homoleptic. Now, in the next question, we have to match the following. See here, this in A, we can see that it can exhibit both trans and cis isomerism. So here Cl is trans and here it would be cis. In next question, EN is a bidentate ligand. So structure for cis would be this. Okay, and you can see it is non-superimposable mirror image and it will exhibit optical isomerism. Okay, the first one was geometrical. Now in the next question, in the next part, see CONH3 whole 5 and NO2 Cl2 is given to us. Now these are ionization isomers. You can see that the exchange of these ligands can take place. And now in these coordination isomerism because change of ligands between these coordination space can take place and these will be our coordination isomerism. So what would be our answer? Our answer would be first. Now in the next question, we have to match these complex ions with their hybridization. Let's see. Here NiCN4 twice. So the possible hybridization here would be see the coordination number here would be 4 because it is clearly evident. Now CN is a strong ligand, okay, strong field ligand. Therefore, in 4 we have sp3 and dsp2, out of which dsp2 occurs due to strong field ligand. So this would be 4. And here you can see it's 6. Therefore, it is octahedral. Okay, and COF6, out of which F is a weaker field ligand. Therefore, the d orbitals which are outer will participate. This would be matching with sp3 d2. Now, in the next part, C2O4, which is again a bidentate ligand. So, it would be this. Sorry, it would be this. Just a second. Because it is a stronger field ligand. So, the d orbitals which occur before will be participating. Now, in NiCl4, it is the left one, that is sp3. So, our answer would be this. Now, in the next question, which of the following is the correct order of increasing field strength? So this we'll see according to the order we all know, spectrochemical series, which will give us the correct order of increasing field strength. So this is the spectrochemical series. You all have to learn it. So the correct answer would be this. CN would be the stronger. Then this would come. Oxalate ion would come. Then fluoride and then Sc. Now the next question is, the ratio of salt is to base is given 10 is to 1 for a basic solution. If pKb of a base is this, we have to find pOH. Okay, so what is the pOH? We'll be using Henderson-Hasselbalch equation here. Okay. So where were we? So we will be using Henderson-Hasselbalch equation here. Just a second. So the equation would be pOH equals to pKb plus log ratio of salt and base. So it is given us 10 is to 1. So we will put this, and what we will have is pOH equals to pKb is given to be 5. Okay. Therefore 5 plus log of 10. What it would be 1. So the answer will be 6. Now in the next question, let's see. Arrhenius equation, the plot of log k against 1 by t is a straight line. The slope is r square. See, we all know that this is the Arrhenius equation. Upon taking log in values, we will have this, and it will be fitting the straight line equation y equals to this. And according to the slope would be, see, this is 1 upon t would be x, therefore m would be minus ea by r. This would be y equal, the straight line equation is y equals to mx plus c. Okay. Now in the next question, so here the correct option would be C. In the next question, the rate of reaction between two reactants A and B decreases by a factor of 4. Concentration of B is doubled. The order of the reaction with respect to reactant B. This is asked. What we have to tell, what is the order of the reaction with respect to B. Okay. So let us consider that rate is proportional to A to the power m and b to the power n. Let us suppose it is r. Okay. Or we can say it is 1. And it is said that in the question, but it decreases by a factor of 4 if we double concentration of b. So what we will get? Am and by 2b because it's given. And it would be 1 by 4. So from equation 1 and from equation 2, when we will compare, this is what we will get. And finally, on comparison, n would be equals to minus 2. How I wrote this? 1 upon 4 can be written as 1 upon 2 to the power 2. That is 2 to the power minus 2. Okay. Let's see the next question. The time taken for the completion of 3 by 4 of a first order reaction is C. The equation here, the formula we'll be using is T equals to 2.303 upon K log initial concentration upon what is the final concentration. What will be a final concentration? It would be 1 minus 3 by 4. Why? Because it is given that time taken for this completion of reaction. So how much is left? This would be left. Okay, if I consider 1 to be my initial concentration. So it would be this. This factor will be equal to this factor. Okay. If it is, yeah. So it would be equals to this factor. This is the remaining amount, 1 minus 3 by 4. And after solving this, you will be getting 2.303 upon K log 4. What is this? Now in the next question, which one of the following statements for the order of a reaction is incorrect? We have to tell incorrect statement. Let's see. We know order can be determined experimentally, yes. Order is not influenced by stoichiometry coefficients of the reactants. Yes, this is also correct. In complex reaction, it is never affected. Now, order of reaction is sum of power of concentration of reactants. Yes, this is also correct. Order of reaction is always whole number. This is wrong. So this would be our answer. It can be fraction. Okay, it can be fraction. Now the next question is CaF2 has solubility this much per 100 ml at 25 degrees Celsius. What is asked? KSP is asked. Solubility product, that is KSP, is asked. And atomic mass of Ca and fluorine is given to us. Now let us move to the solution. If solubility is given for CaF2, that is, it is S, and we will be converting it to gram per liter. So we'll be multiplying it by factor of 10 raised to the power minus 3. And molar mass of CaF2 is this. So what will be the molar solubility? We will divide these two. And what we will get? 2 into 10 to the power minus 4. Now see that in a reaction between for this, it would be equals to Ca2 plus 2F minus. Okay. So if M1 is the concentration of this, then M2 and then 2M1 would be there because two fluoride ions are there. Okay. So what we will have is KSP can be written as this, and therefore it would be M into 2M. Okay, and square of that because two fluoride ions are there. So upon solving this and putting the values, we will get the answer to be 3.2 into 10 to the power minus 11. Now in the next question, it is given that a buffer solution is prepared by mixing 0.01 molar ammonia and 1 molar ammonium chloride. With 298 Kelvin, the pKb is given for NH4OH, where pOH of the buffer has been asked. So again, we'll be using the same equation, Henderson-Hazelbach equation. And we have to find the pOH. pKb is already given 5, and we have been given the other factors 1 and zero point zero 0.01. Therefore, upon solving this, we will get the answer 7. Now, in the next question, 2 moles of HI were heated in a sealed tube at 440 degrees Celsius till the equilibrium was reached. HI was found to be 22% decomposed. This much has already decomposed. Now, Kc is asked for dissociation. Let's see, for decomposition of 2HI, this would be the equation. Alright. And initially, 2 moles are given. And so initially we only have reactant, no product is there. So it would be 0, H2 and I2. Now at equilibrium, it is 22% is decomposed. Therefore, how much is left? Whatever initial is given minus 22%. Okay. So it would be, why multiply by 2? Because 2 moles are given. Okay. So this would be there. And whatever will decompose, that will only form the products. So 0.22 will be the product for H2 and I2. And upon solving this, we will get 1.56. Now we know the how to write the equilibrium constant, concentration of products upon reactants. So upon putting the value, we will get this answer. Now in the next question, which one of the following for informations can be obtained on the basis of Leach-Atelier's principle? See, according to Leach-Atelier's principle, if a system subjected to change in concentration, pressure, or temperature, the equilibrium shifts in the direction that tends to undo the effect. If for example, say if my product or if anything is moving in the forward direction. Okay, so what happens in the equilibrium? There should be a balance. So the equilibrium will tend to move in the backward direction. Okay, it will try to undo the effect so that it can be at equilibrium. So constant of a chemical reaction can be calculated by that. Okay, it never tells entropy change that is told by the thermodynamics. Okay, now in the next question, the value of del G naught for the phosphorylation of glucose in glycolysis is 13.8 kilojoule per mole. What is the value of Kc? See, this is really easy. We'll be just using the formula we know. Del G is given to us. We'll convert it into joules per mole. Now this is the formula for del G equals to minus RT ln Kc. So just upon solving this, upon putting the values in solving, we'll get Kc to be this. Okay, so it will correspond to 4. Now in the next question, which of the following statement is incorrect regarding equilibrium state? The value of del G at equilibrium is 0. This is right. The reaction ceases at equilibrium. No, this is wrong. The reaction never ceases at equilibrium. It is in the state of equilibrium. It never stops. Okay. And in the next option, it is given that equilibrium constant is independent of the initial concentration. This is also true. It depends only on concentration which are present at equilibrium. Catalysts have no effect on equilibrium state. Yes, this is also true. Now in the next question, consider the following reaction. Okay, the standard enthalpy of combustion of hydrogen, cyclohexane, cyclohexane are given to be these. And what is asked? The standard enthalpy of hydrogenation of cyclohexane. Okay. So see what is the required reaction. This is the required reaction. And what is given to us? Combustion of these species. See, now what we need cyclohexane as reactant. It is present as reactant. Hydrogen, it is also present as reactant. And cyclohexane. Now this is present as a reactant, but we need it as a product. So we'll add the equation number 2 and 3 and subtract equation number 4 for del H. Okay. So this would be the solution. And answer would be corresponding to fourth option. Now in the next question, we have to again match the columns. Okay. See here. Oxidation number of oxygen in OF. See, fluorine is the most electronegative element. So what we will do is oxygen X plus 2 into minus 1. Therefore, it would be plus 2, okay, in OF2. In H2O2, it is a peroxide. And in peroxide, it will always be minus 1 for oxygen. In RbO2, see, it is superoxide. So it would be minus 1 by 2. In O2F2, then again it would be 2x minus 2 equals to 0. So x would be equals to plus 1. So this would be the correct answer. Now the next question. The enthalpies of elements in their standard states are taken as 0. The enthalpy of formation of a compound is, see, enthalpy of formation of a compound, that is delta H. Okay, now it will depend if the reaction is exothermic or endothermic. It would be negative for exothermic reaction, positive for endothermic reaction. So it can be positive or negative. Okay. Now in the next, which of the following is not a state function? Which out of these, work is not a state function. Why? Because it is the path function. It depends on the path followed. This does not depend on the path followed. Okay. In the next question, in 71, this is the reaction given to us. Okay. And we have been asked that the above given reaction is oxidation reaction. Why it is oxidation reaction? See, in this, removal of K plus K is taking place. That is an electropositive element. From here, it is K4 here and it is K3. That is oxidation is occurring because of removal of electrons. So this would be the answer here. Now, in the next question, let's see. When a gas undergoes adiabatic expansion, it gets cooled due to why it gets cooled. See, we all know from first of thermodynamics, del U equals to Q plus W. Now, for an adiabatic process, always remember Q will be equals to 0. Then what we are left with, del U would be equals to W. Okay, and W equals to minus P delta V. And for expansion, whenever expansion is there, del V would be positive because upon expansion, volume will be increasing. Okay, so this would be our final expression that we will be having from this to this. So change in internal energy is negative. That is temperature fall is there. So what would be our answer? Fall in temperature. Let's see the next question. Which of the following is correct for isothermal expansion of an ideal gas? C for isothermal expansion. Isothermal, if any process is isothermal, then T would be constant. That is delta T would be 0. Now we know that in delta U formula is in CV delta T. Therefore, if this is 0, then whole will be 0. And similarly for delta H, it would be 0. Therefore, these are unchanged. Now let's see the next question. The pressure volume work for an ideal gas can be calculated by using the expression this, and work can also be calculated from the PV plot using area under the curve within the specified limits. When an ideal gas is compressed irreversibly, being irreversibly from volume V1 I to VF, what is the correct option? What is asked? That if we reversibly or irreversibly compress, what would be the relation? Now, see this figure. Work done is the area under the PV curve. So it can be seen here that if for irreversible we have this, and for reversible we have this. And what would be the area here? So the area for reversible is lesser than area for irreversible. Okay. Therefore, work done for irreversible should be more. So this would be the correct answer. Now in the next question, identify the species with an atom in +6 oxidation state. So let's calculate. In MnO4 negative, let's see, +4 into -2 equals to -1. Therefore, X would be +7. Okay. Here it would be +3 for chromium. Here nickel would be in +4. Here, what would be the case? X -4 minus 2 equals to 0. Therefore, X equals to +6. So our answer would be CrO2, Cl2. In next question, entropy decreases during. So see, when entropy decreases, when randomness is less. Okay, when we are bounding it. See, in crystallization of sucrose from solution. In liquid, obviously the randomness is more than the solid. Okay, so upon crystallization, the randomness will decrease. So this would be our answer. In the next question, which of the following arrangements represent increasing oxidation number? Let's calculate the oxidation number. See, for CrO2 negative, it would be +3. We all know how to calculate it. ClO3 minus, it would be +5. For this, it would be +6. And again, for MnO4 negative, it would be +7. So now we can arrange it clearly. Let's see the next question. Assertion is given the resistivity for a substance is its resistance when it is 1 meter long and its area of cross section is 1 square meter. The SI unit of resistivity is given to be ohm meter. Let's see, both of these are true, but the reason does not state the assertion. Reason is not explaining it. So our option would be true. Now, see. R, what is R? Resistance equals to resistivity L by A. If this is 1 and this is 1, resistance will equals to resistivity obviously. So that is why assertion is true and reason is also true. Let's see the next question. A solution of copper sulfate is electrolyzed for 10 minutes. This is the time with a current of 1.5 amperes. The mass of copper deposited at the cathode and atomic mass of copper is given. See how we will do it. We all know that W equals to Z I T. I is current, T is the time in seconds. So for Z, what we will do, Z is the chemical equivalent, electrochemical equivalent. Okay. So how we calculate the equivalent weight of copper? By its atomic weight, what is given to us upon change in electrons, that is 2, and it will come out to be 31.5. Then for Z, what we will do is equivalent weight divided by the number of Faradays we have. That is 96500. And we'll just substitute the following. Time is in seconds, so we'll multiply by 60. And the final answer would be this. Now, in the next question, which of the following statement is not correct about inert electrode in a cell? Inert electrode does not participate. This is correct. It provides surface for either oxidation or reduction. This is also correct. This is also correct that it provides surface for conduction of electron. This is wrong. Therefore, this would be our correct answer. Okay. Now, in the next question, calculate the time required to deposit 2 into 10 to the power minus 3 centimeter thick layer of silver whose density is given to us on the surface of area this much by passing a current of 10 amperes through silver nitrate solution. Okay, so we have to find the time. See, what we will do? Mass of silver. We all know that density equals to mass upon volume. So what will be mass? Mass will be equals to density into volume. Okay. So we'll just multiply volume. Here, what is given? Length and area, and volume equals to length into area. Okay. So this multiplied by density, we will get this. And now we'll just substitute in this formula that we used earlier as well, and we'll get answer to be 18.7 seconds. Let's see the next question. The difference between electrode potentials of two electrodes when no current is drawn through the cell is called. See, here, what is electrode potential first of all? It is the tendency of an electrode to lose or gain electrons when it is in contact with the solution of its own ions. Okay. So in any electron, what will be cell potential? Okay, it would be independent of cathode and anode, and they'll have some electrode potential of their own. So cell potential would be, I'll write it here. E cell would be E cathode minus E anode. Okay. What is cell EMF? It is the energy provided by a cell or a battery per coulomb of charge passing through it. Okay. And it is when no current is flowing. So this would be our answer. Let's see the potential difference. Potential difference is the amount of work to be done to move a unit positive charge from one point to another. Okay, it does not remain constant. It will either drop or increase. Okay, and we all know cell voltage. It is the voltage of the cell. Okay, we can calculate using voltmeter. Now in the next question, select the correct statement. Atoms of all elements are composed of two fundamental particles. No, because they also have neutrons. So it have three particles: protons, electrons, and neutrons. The mass of electron is 9.1 into 10 to the power minus 31 kgs. This is right. All isotopes of given element show same chemical properties. Yes. Protons and electrons are collectively known nucleus. No. Neutrons and protons will be collectively known as nucleons. Okay. And Dalton's atomic theory is regarded as that atom as an ultimate particle of matter. This is also true. Therefore, 2, 3, and 5 are okay. So, in the next question, what is asked? That we have to tell which of the following is isostructure. That is, they have same structure, same shape, and hybridization. See here. In BCl3, it is obviously trigonal planar. In BrCl3, it is C-shaped. Okay, and it is sp2 and this is sp3d2. In NH3 and NO3 negative, this is tetrahedral. It is again trigonal planar. NF3 and BF3, this shape is pyramidal. Okay, and BF3 is trigonal planar. These are both tetrahedral. Okay, so they'll have same shape and hybridization. sp3 would be the hybridization. Okay, so this is our correct answer. Let's see the next question. The number of electrons ejected in the photoelectric experiment is proportional to the how much number of electrons will be ejected will be depending upon how much photons which will receive. That is, how much is the intensity or the brightness of the light. So this would be the correct answer. Okay. Why? Because intensity of light is directly related to the number of photons. More intense the light is, more will be the number of photons and more will be the electrons ejected. Now in the next question, cathode rays have same charge to mass ratio as beta rays because beta rays are negatively charged, which are particles similar to electrons. Now, in the next question, which of the following two species have trigonal pyramidal shape? Okay. Let's see. In Ni3, this has a trigonal pyramidal shape, and the ion with formula for SO3 2 negative. This would be the structure for NO3 negative. This would be the structure. And for I3 negative, it would be the structure. How we calculated this, how we found this out? We'll do like this. Okay. So I would be the central atom as well. So now, how we will do? I here. Okay. So now it will have three lone pair because one extra electron is added here. Okay. So that is why this would be the structure of I3 negative. Make sure that you know the structure of I3 negative and I3 positive. Okay, these are very important. So let's move forward to the next question. If the radius of the second Bohr orbit of helium plus ion is this much, what is the radius of third Bohr orbit of Li2 positive? Okay, let's see. Radius would be proportional to n square upon z. So for third orbit of Li plus 2, N1 would be 3, Z1 would be 3. Hydrogen, helium, lithium, so obviously Z is 3. For second orbit of helium, N2 and Z2 would be 2. We'll just take their ratios and upon putting the values, we'll get this answer. Okay. Pay attention to the unit C, angstrom and picometer. So it would be confusing there. Let's see the next question. The energy of an electron in the ground state N1 n equals to 1 for helium positive is minus x joules. Then that for an electron in n equals to 2 with Be plus 3 ion in joules is C. We all know that En equals to minus Z square RH upon n square. Now for helium, Z would be 2 and it is said that n equals to 1. So we'll just put the formula. It is given that energy for this state is minus x. Okay. So we'll put this in the formula and we'll have minus x equals to minus 2 square RH upon n equals to 1 is given to us. So we'll have x equals to 4h RH. So what would be RH? That would be x by 4. Now what we will do is we'll substitute this value of RH in the formula for Be3 positive, where Z would be 4 and N will be 2. So on substituting, we'll get answer to be minus 6. In the next question, following molecules are listed. We have to rank these in increasing order of the boiling point. See, the boiling point always depend on the intermolecular forces. So here you see CH4, it has weak dispersive forces. It has weak forces. Now in ammonia, we have hydrogen bonding. Here also we have hydrogen bonding, which is a relatively stronger force, which is very strong. Okay. BF3 here it is a polar molecule, but it doesn't have hydrogen bonding. It do have forces, but it does not have hydrogen bonding. So see, this will be least. Okay, and then we have BF3. Now, among ammonia and water, see, oxygen is more electronegative than nitrogen, so it has a better hydrogen bonding, which boiling point will be more. Okay, so this would be our answer, which corresponds to 3. Let's see the next question. See, in this question, it is very easy. You can just see by the coordination number it has. Okay. So where it is 2, that is obviously linear. Where it is 3, that is trigonal planar. It is 4, that is tetrahedral. Okay. So it will be corresponding to this. Let's see the next question. Find out the osmotic pressure of 0.1 monobasic acid. pH is given. If pH is 2, then what would be H plus ion concentration? Obviously, it will be 10 to the power minus 2. 25 degrees Celsius. So let's calculate. See, if this is the reaction given to us, and initially it is this. So obviously after some time it would be C minus C alpha, or we can write it in this manner, and C alpha would be formed. Okay? And the concentration of H plus is C alpha. Also we know it is given that it is 10 to the power minus 2. So here we'll find alpha. Now for the total particles in the solution, we'll be adding all alpha we have. That is 1 minus Alpha plus alpha, that is 1 plus alpha we'll have. And this would be 1.1. Now pi will be CRT into I. Okay, this is our I. So final answer would be 2.69 ATM. See, unit is ATM. So what would be R? R would be 0.0821, which is in ATM. Do not use 8.314 or 2 here. In the next question, sorry. If alpha is the degree of dissociation of Na2SO4 in one factor I used for calculating the molecular mass is C. If this is our reaction for the dissociation, and these are the moles 1, and for product obviously it would be 0. So after some time these would be alpha would be subtracted from here, and these would be 2 alpha because 2 and a positive are there, and this would be 1 alpha. So we'll just add these. We'll get the total I. Okay, that would be 1 plus 2 alpha. Now let's see the next question. The relationship between osmotic pressure at 273 Kelvin when 10 gram of glucose, 10 gram of urea, and 10 gram of sucrose are dissolved in this much amount of water. See, we know that V equals to W upon MV. So it would be inversely proportional to volume and mass. Volume is constant, so it will be proportional to mass. We'll be taking mass. So, what is the molecular weight? See, for sucrose, it is 342, urea 60, and glucose 180. So, this has maximum mass, so it will have lowest osmotic pressure. So, our final answer would be this. Sorry. Yeah. Same. Now, let's see the next question. What is the unit of molarity? It's moles per liter. Amount dissolved in 1 molars, okay? 1 liter of solution. Number of moles dissolved in 1 liter of solution. Mole, obviously it is mole. Mole fraction, it is a fraction, so it is unitless. And molality, amount and moles dissolved in 1 kg of the solvent. So this would be the answer. Now let's see the next question. Statement 1 is the empirical formula of a compound. If the molecular mass of a compound is 80, and the compound contains 60% carbon, 5% hydrogen, 35% of nitrogen is given to be this. Statement 2 says molecular formula is C4H4N2. See, so what would be how much will be the moles of nitrogen? These would be 35 upon 40. For hydrogen, 5%, and because 5% is given, therefore 5 upon this. And for carbon, see, 100 gram was given to us. Okay, and it is consisting of 35% nitrogen and 5% hydrogen and 60% of carbon. Therefore, 35, 5, and 60 would be the given masses. So, these are the ratio of moles. Now, see, if we put these, see, for nitrogen we have 2.5, for hydrogen we have 4.9, and for carbon also we have 4.9. Now, this is the smallest one, so we will divide it by this because we divided by the smallest to find the empirical formula. So what we will get is 1 is to this, and we'll write it in the whole number. So this would be the empirical formula. Our statement 1 is correct. Now let's find the molecular formula. How do we find it? We multiply it by n, empirical formula into n. And how we will calculate n? N will be calculated by molecular mass upon empirical formula weight that is given to us. The empirical formula is here. We will find the weight. So carbon atoms are there, therefore 12 into 2 plus 2 hydrogen and 1 nitrogen. So it is 40. So 80 divided by 40 equals to 2. So we'll multiply the empirical formula by this. We have C4H4N2. So both the statements are correct. Let's see the next question. The vapor density of gas A is 4 times to that of B. If the molecular mass of B is m, then the molecular mass of A. This is easy. Molecular mass equals to 2 into vapor density. So let for A and for B be mb. We'll just divide these, and what we have, 2 into vapor density of A upon 2 into vapor density of B, which is given that it is 4 times. For A, it is 4 times of B. So what do we have? We have MA equals to 4 into MB. If we consider, it is given that molecular mass of B is M. This is M. So what would it be MA? MA would be 4M. Okay. Let's see the next question. We have to match these options. See, molarity, it depends upon temperature. Molality, mass percent, and mole fraction. These are independent of temperature, but molarity depends on temperature because volume also. Okay, so volume will also depend on temperature. Molality, this depends on the moles of solute. Volume percent, it depends on volume of solution. Mass percent, it does not depend on volume. Okay, so our correct answer would be 3. AP, R, S, yeah. See here. A, that is molarity. It would be P, and see, molarity depends upon temperature as well as volume, number of moles in 1 liter of volume. So that is why it is P and both are. Okay? And for B, molality does not depend on temperature. Okay, so it would be molarity would also be S. Okay, because it depends on wait. Let me make it more clear. Hmm. Mass percent, mole fraction, and molality. These are temperature independent. Okay, and molarity, it depends on temperature. Okay, so see, now why it is, because molarity depends on the volume and volume depends on temperature, whereas mass will not depend on the temperature. Okay? Temperature depends only on volume. So according to that, we will be matching the options. Okay? Now let's see the next question. What does the following figures represent? C. For an ideal solution, it is not the case. Okay. For non-ideal solution, it would be this. And this would be negative deviation. And this would be positive deviation from Raoult's law. So it is non-ideal solution. And this is negative deviation. So this would be the answer. Let's see the last question. Which of the following statements are correct for KF? Okay. Now, the proportionality constant Kf, it depends upon the nature of the solvent. It is also known as freezing point depression, molar depression constant, and cryoscopic constant. So, therefore, all the statements are correct. Okay, and its unit would be kg, Kelvin, kg inverse, Kelvin, kg, mole inverse. Okay, so that's all for today. Let's meet in the next solution video.